Regular expression operations. Source leaf slash re slash. This module provides regular expression matching operations similar to those found in Perl. Both patterns and strings to be searched can be Unicode strings str as well as 8-bit strings bytes. However, Unicode strings and 8-bit strings cannot be mixed. That is, you cannot match a Unicode string with a bytes pattern or vice versa. Similarly, when asking for a substitution, the replacement string must be of the same type as both the pattern and the search string. Regular expressions use the backslash character to indicate special forms or to allow special characters to be used without invoking their special meaning. This collides with Python's usage of the same character for the same purpose in string literals. For example, to match a literal backslash, one might have to write backslash 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 as the pattern string because the regular expression must be slash slash and each backslash must be expressed as slash slash uh, inside a regular python string literal. Also, please note that any invalid escape sequences in python's usage of backslash in string literals now generate a syntax warning, and in the future this will become a syntax error. This behavior will happen even if it is a valid escape sequence for a regular expression. So let's try examples.py, and here print backslash backslash run prints this. What would be the example of invalid accept sequence? The solution is to use Python's row string notation for regular expression patterns. Backslashes are not handled in any special way in a string literal prefixed with R. So R backslash n in a two character string containing backslash and n, while backslash n is a one character string containing a new line. Using patterns will be expressed in Python code using this row string. Okay, let's go again. So m slash n, this will be new line. So this will be new line, and if we use row string, that will be same as what is being entered into the string itself. It is important to note that most regular expression operations are available as module level functions. Module level functions methods on compiled regular expressions. The functions are shortcuts that don't require you to compile a regular expression object first but miss some fine tuning parameters. See also the third party regx module which has an API compatible with the standard library RE module but offers additional functionality and a more thorough Unicode support. Third party regex 2020. Okay, this is third party regular expression. Mhm. These are the usages. Okay. Okay. Let's go back to here. Regular expression syntax. A regular expression or RE specifies a set of strings that matches it. The functions in this module let you check if a particular string matches a given regular expression or if a given regular expression matches a particular string, which comes down to the same thing. Regular expressions can be concatenated to form new regular expressions. If a and b are both regular expression, then ab is also a regular expression. In general, if a string p matches a and another string q matches b, the string pq will match ab. This holds unless A or B contain low precedence operations, boundary conditions between A and B, or have numbered group references. Thus, complex expressions can easily be constructed from simpler primitive expressions like the ones described here. For details of the theory and implementation of regular expression, consult the Fried, Friedel book F Free 09 or almost any textbooks another compiler construction. A brief explanation of the format of regular expressions follows. For further information and a gentle presentation, consult the regular expression how to. Regular expression how to. Okay, so here is the list of okay. Hmm. It is also a part of Python documentation. Okay, let's go back to here. Finish this one first. Regular expressions can contain both special and ordinary characters. Most ordinary characters like A, capital A or 0 are the simplest regular expressions. They simply match themselves. You can concatenate ordinary characters so last matches the string last. In the rest of this section we will write REs regular expressions in this special style, usually without quotes and strings to be matched in single quotes. Some characters like pipe, that is or small inverted small bracket are special. Special characters either stand for classes of ordinary characters or affect how the regular expressions around them are interpreted. Repetition operators or qualifiers. What are repetition operators and qualifiers? So these are bracket, small bracket, asterisk, star, comma, plus, comma, question mark, comma, in curly brace m, comma, n. That is for I think range, etc. cannot be directly nested. They cannot be directly nested. This avoids ambiguity with the non-greedy modifier suffix question mark and with other modifiers in other implementations. To apply a second repetition to an inner repetition, parenthesis may be used. For example, the expression parenthesis question mark colon a in curly brace 6 parenthesis and star matches any multiple of 6 a characters. Okay. The special characters are, so following are the special characters. Dot. In the default mode, this matches any character except a new line. If the do dot all flag has been specified, this matches any character including a new line. XOR operator caret matches the start of the string and in multi-line mode also matches immediately after each new line. Okay, so let's take a note of it somewhere. So new special chars dot then caret matches any character except new line. Start of string. Dollar matches the end of the string or just before the new line at the end of the string. Dollar dollar matches the end of the string or just before the new line. Okay, just before the new line at the end of the string. And in multi-line modes also matches before a new line. Foo matches both foo and foo bar, while the regular expressions foo dollar matches only foo. More interestingly, searches for foo dot dollar in foo1 backslash n foo2 backslash n matches foo2 normally, but foo1 in multi-line mode searches for a single dollar in foo backslash n will find two empty matches. One just before the new line and one at the end of the string. Star causes the resulting regular expression to match 0 or more repetitions of the preceding regular expression. Causes the resulting RE regular expression to match 0 or more occurrences repetitions of preceding RE. As many repetitions are possible, A B star will match A B or A followed by any number of B's. Plus causes the resulting RE to match one or more repetitions of the preceding RE. Causes the resulting RE to match. Okay. A B plus will match A followed by any non-zero number. A followed by any non-zero number of b's, it will not match just a. Question mark causes the resulting regular expression to match 0 or 1 repetitions of the preceding re. Question mark. Okay. A B question mark will match either A or AB. Star question mark plus question mark question mark. The star plus or question mark quantifiers are all greedy. All greedy. They match as much tags as possible. They match as much text as possible. Sometimes this behavior is not desired. If the regular expression dot star is matched against A, B, C, it will match the entire string and not just A. Not just A. Adding question mark after the quantifier makes it perform the match in non-greedy or minimal fashion. Non-greedy or minimal fashion. As few characters as possible will be matched using the RE regular expression dot star question mark dot star question mark 0 or 1 will match only A. Okay. Star comma plus comma question mark non greedy quantifiers. Star plus comma question mark plus. Like the star plus or question mark quantifiers, those where plus is appended also matches as many times as possible. As many times as much possible. However, unlike the true greedy quantifiers, these do not allow backtracking when the expression following it fails to match. These are known as possessive quantifiers. For example, A star A will match A because the A star will match all four A's, but when the final A is encountered, the expression is backtracked so that in the end of A star ends up matching 3S total, and the fourth A is matched by the final A. However, when A star plus A is used to match A, the A star plus will match all 4A, but when the final A fails to find any more characters to match, the expression cannot be backtracked and will thus fail to match. Uh, X star plus X plus plus and X question mark plus are equivalent to question mark greater than X star question mark greater than X plus and question mark greater than X correspondingly. New in 3.11, M specifies the exactly M copies of the previous regular expression should be matched. M exactly M copy of specifies exactly M copies of the previous regular expression should be matched. Fewer matches causes the entire regular expression not to match. For example, A6 will match exactly 6 A characters but not 5. MN causes the resulting regular expression to match from M to N repetitions of the preceding RE. attempting to match as many repetitions as possible. For example, A35 will match from 3 to 5 A characters. Omitting M specifies a lower bound of 0 and omitting N specifies an infinite upper bound. As an example, A4B will match AAAAB or 1,000 A characters followed by B, but not AAAB. The comma may not be omitted, or the modifier would be confused with the previously described form. M, comma N question mark causes the resulting regular expression to match from M to N repetitions of the preceding regular expression, attempting to match a few repetitions as possible. This is a non-greedy version of the previous quantifier. For example, on the 6 character string AAAAAB, A3 to 5 will match 5 A characters, while A35 question mark will not only match will only match 3 characters. Why not 5? Okay, few, that's why. Mn plus causes the resulting RE to match from M to N repetitions of the preceding RE, attempting to match as many repetitions as possible without establishing any break backtracking. Without establishing any backtracking. This is true possessive version of the quantifier above. For example, on the 6 character string AAAAAA, A35 A35 plus AA attempts to match 5 A characters, then requiring 2 more A's will need more characters than available and thus fail. While A35AA will match with A35 capturing 5, then 4 A's by backtracking, and then the final 2 A's are matched by the final AA in the pattern. XMN plus is equivalent to question mark greater than X MN. Either escapes special characters permitting you to match characters like star, question mark, and so forth, or signals a special sequence. Special sequences are discussed below. If you are not using a row string to express the pattern, remember that Python also uses the backslash as an escape sequence in string literals. If the escape sequence is not recognized by Python's parser, the backslash and subsequent characters are included in the resulting string. However, if Python would recognize the resulting sequence, the backslash should be repeated twice. This is complicated and hard to understand, so it's highly recommended that you use a row strings for all but simplest expression. Square brackets used to indicate a set of characters used to indicate set of special characters. Characters can be listed individually. Example, AMK will match AM or K. Ranges of characters can be indicated by giving two characters and separating them by a hyphen. For example, A to Z will match A to Z will match any lowercase letters. 0 to 5, 0 to 9 will match all the two digit numbers from 00 to 59. 00 to 59. And and 0 to 9 AF 0 AF will match any hexadecimal digit. If hyphen is escaped, example a hyphen minus z, or if it's placed as the first or last character minus a or a minus, it will match a literal minus. Special characters lose their special meaning inside sets. For example, uh, parenthesis plus star will match any of the literals parenthesis plus star or parenthesis. Characters classes such as backslash w, character classes such as backslash w, white space, or backslash s defined below are also accepted inside a set, although the characters they match depend on the flags used. Okay. Okay. Characters that are not within a range can be matched by complementing the set. If the first character of the set is caret, all the characters that are not in the set will be matched. For example, this caret 5 will match any character except 5, and caret will match any character except caret. Caret has also meaning. Character 5 will match any character except 5. Caret has no special meaning if it is not the first character in the set. To match a literal this inside a set, precede it with a backslash or place it at the beginning of the set. For example, both will match a right bracket as well as left bracket, braces, and parentheses. Support of the nested sets and set operations as in Unicode Technical Standard 18 might be added in the future. This would change the syntax, so to facilitate this change, a future warning will be raised in ambiguous cases for the time being. That includes sets starting with a literal square bracket or containing literal character sequences hyphen hyphen ampersand tilde tilde and or to avoid a warning escape them with a backslash. Changed in version 3.7, future warning is raised if a character set contains constructs that will change semantically in the future. A or B, where A and B can be arbitrary regular expressions, creates a regular expression that will match either A or B. An arbitrary number of regular expressions can be separated by or in this way. This can be used inside groups, see below as well. As the target string is scanned, R is separated by or are tried to form left to right. When one pattern completely matches, that branch is accepted. This means that once A matches, B will not be tested further, even if it would produce a longer overall match. In other words, the OR operator is never greedy. To match a literal OR, use backslash or enclose it with a character class as in this. ellipsis dot 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 in parentheses matches whatever regular expression is inside the parenthesis and indicates the start and end of a group. The contents of group can be retrieved after a match has been performed and can be matched later in the string with the backslash number special sequence described below. To match the literals, parentheses use backslash parentheses or backslash end of parentheses and enclose them inside the character class this. Question mark parenthesis, question mark ellipsis, one or more. This is an extension notation. A question mark, a question mark following a parenthesis is not meaningful otherwise. The first character after the question mark determines what the meaning and future syntax of the constructor is. Extensions usually do not create a new group. Question mark p name is the only extension to this rule. Following are the currently supported extensions. Question mark AILMSUX. One or more letters from the set AILMSUX. The group matches the empty string. The letters set to the corresponding flags for the entire regular expression. RE.A ASCII only matching. RE dot capital I ignore case. RE dot L local dependent. RE dot M multiline. RE dot S dot matches all. RE dot U Unicode matching. RE dot X verbose. The flags are described in module contents. This is useful if you wish to include the flag as part of the regular expression. Instead of passing a flag argument to the re.compile function, flags should be used first in the expression string. Question mark colon dot dot dot. A non-capturing version of the regular expression matches whatever regular expression is inside the parentheses. But the substring matched by the group cannot be retrieved after performing a match or reference later in the pattern. Zero or more letters from the set A, I, capital L, M, S, U, X, optionally followed by hyphen followed by one or more letters from the I, M, S, X. The letters set or remove the corresponding flags for the part of the expression. Okay, these are the flags are described in module contents. The letters A, capital L and U are mutually exclusive when used as inline flags, so they cannot be combined or follow hyphen. Instead, when one of them appears in an inline group, it overrides the matching mode in the enclosing group. In Unicode patterns, question mark A colon dot 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 switches to ASCII only matching, and question mark U colon dot 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 switches to Unicode matching default. In bytes pattern, question mark L colon dot 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 switches to local dependent matching, and question mark A colon dot 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 switches to ASCII only matching. This overrides is only in effect for the narrow inline group, and the original matching mode restored outside the group. Question mark greater than dot 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 attempts to match dot 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 as if it was a separate regular expression, and if successful continues to match the rest of the pattern following it. If the subsequent pattern fails to match, the stack can only be unwound to a point where the question mark greater than dot dot dot, because once exited the expression known as An atomic group has thrown away all stake points within itself. Thus, question mark greater than dot star attempts to match dot 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 as if it was a separate regular expression, and if successful continues to match the rest of the pattern following it. If the subsequent pattern fails to match, the stake can only be unwound to a point where before the question mark greater than dot 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 because once existed. The expression known as an atomic group has thrown away all stake points within itself. Thus, question mark greater than dot star would never match anything because first the dot star would match all characters possible. Then, having nothing left to match, the final dot would fail to match. Since there are no stake points saved in atomic group and there is no stake point before it, the entire expression would thus fail to match. Question are capital P less than name greater than dot dot dot. Similar to regular parentheses, but the substring matched by a group is accessible via the symbolic group name. Group names must be valid Python identifiers, and in bytes pattern they can only contain bytes in the ASCII range. Each group name must be defined only once within a regular expression. A symbolic group is also a numbered group, just as if the group were not named. Named groups can be referenced in three contexts. If the pattern is question mark capital P less than quote greater than bracket square bracket single inverted comma double inverted comma dot star question mark bracket parenthesis question mark P is equal to quote P is equal to quote. Example, matching a string quoted with either single or quoted double quotes. Context of reference to group quote. Way to reference it. In the same pattern itself, question mark P is equal to quote as shown backslash 1. When processing match object m dot group quote m dot and quote etc. in a string passed to the rep l argument of re dot sub backslash g quote backslash g1 backslash 1 question mark capital P is equal to name, a back reference to a named group. It matches whenever text was matched by the earlier group named B. Then question mark hash dot 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 a comment. The contents of the parentheses are simply ignored. Question mark equal dot 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 matches if dot 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 matches next but doesn't consume any of the string. This is called a look ahead assertion. For example, Isaac question mark equal to ASIMOV will match Isaac only if it's followed by asimo question mark exclamation dot 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 matches if dot 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 doesn't match next. This is negative look ahead expression. For example, Isaac question mark question mark exclamation asimo will match Isaac only if it's not followed by asimo. Question mark less than equal to dot 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 matches if the current position in the string is preceded by a match for dot 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 that ends at the current position. This is called a positive look ahead look behind assertion. Question mark less than equal to abcdef will find a match in ABCDEF. Since the look behind will back up three characters and check if the content pattern matches. The content pattern must only match strings of some fixed length, meaning that ABC or A or B are followed, but A star and A 3 4 are not. Note that patterns with which start with positive look behind assertions will not match at the beginning of the string being searched. You will most likely want to use the search function rather than the match function. Import re m is equal to re dot search. This is the regular expression in parenthesis question mark less than equal to abc def m dot group 0 def. Let's do the coding part. Import re print m. Let's check. Stop it. Re dot match object span is equal to 3 to 6, match is equal to def. Okay, print m dot groups bracket print m dot group 0 def. Print m dot group 1 no such groups. Okay. This example looks for a word following a hyphen. Okay, thank you.